On this type of crank sensor, it actually makes the voltage going to the ECM. So when you have the reluctor go across it, that's what produces the voltage and change the resistance. As you can see on this, I have it back probed through the ECM connector unplugged to the crank sensor at these positions.
Meter. Now you also can use the component testing if you want to, but I'm just going to go ahead and show you how to use it with the scope side. So graphing multimeter, and then we're going to go to ohms. Set it at 400 or 4K, and we can keep it at 1 minute because I want to kind of show you guys the different ways to do this. So you can see it's at 0.600 ohms, so it's at 600 ohms. 0.6, yep, at the 3, 600 ohms.
Just shake it, the magnet around, and then you will see the pulse.
Or 0.6K. And then now I'm going to put the magnet across the sensor, and it should squirmy. As you see, as I move it, you can connect with it, you can see the resistance change. So that tells me that that circuit is good. So if I go faster, say 5 seconds, and do the same thing, you're going to be able to tell more. You got to remember, all this is a magnet, and it goes across the reluctor, and it makes a signal. Now you can really see it. Now the crank sensor, as you see, is off. And all this is doing is telling you that the circuit is good. Now, if we want on the voltage side, so we're just going to go to voltage, graphing meter, volts, voltage. To get a better view of it, we can even drop this down to, say, 1 volt, and then take our time, and then this way we can actually really see the magnetic pulse every time we go across it. So all we're really doing is testing the circuit at the crank sensor to make sure it's good from here down to underneath. So this is a good way to test the circuit, good way to test your crank sensor. Now, it doesn't mean that the crank sensor, well, this one is.
I want to thank you for watching this YouTube. Please hit the like button and subscribe, and hit the bell for notification. Thanks.